Let's solve for the concentration of HI at equilibrium. We're not given information at equilibrium, which is what we want in order to use equilibrium expression. In this case, going to be the concentration of products, which is HI. Square that over the concentration of the reactants. All right, in order to use this expression, we need conditions at equilibrium, and we don't have that. So when we are given initial conditions, we can use what's called an ice box or an ice table or ice chart. Okay, so I'm going to put the initial, the change, and concentrations at equilibrium. We're given the initial concentrations for H2 is 0.5 molar and I2 at 0.5 molar. Okay. Initially, the products have not been made, so that's going to be 0 molar, and we are not given anything else. The key here, I'll do this in green, is to use these stoichiometric molar ratios to identify the change. For every one H2 that is being used, we're also going to use one I2, so it's a 1-to-1 ratio. All right, and that's going to produce, I'm going to use a plus sign here to indicate that that is gaining 2 molecules of HI. To get the equilibrium concentrations, it's going to be how much you started with, which is 0.5, and then add the change, and we're going to add a negative quantity, so it's going to be minus x, and so that's just what it is. So we don't know what x is yet. We're going to solve for that in eventually. And the same thing here is we're starting with 0.5, and we're adding the change, which is the change in the reactants is negative. So it's negative x. And over here, you're starting with 0, and it changed by 2x. So at equilibrium, it's going to be 2x. So now we can just plug these in. We're also given k, so let's plug and play. We're almost done. See if I can fit all of this in here. All right, so Kc we're given is 64.0 equals the concentrations of HI is 2x, and we're going to square that because of the coefficient. And we're going to put all that over the concentration at equilibrium now is going to be 0.5 minus x, and they're both like that, so I'm just going to square that. Save a little board space. What I just did was 0.5. All right, so that's the same thing as, and don't try to FOIL this out. You're going to make it more complicated. When you have a perfect square like this, and you can see they're all perfect squares everywhere, take the square root from here to get rid of all these exponents. So let's do that. Take the square root of both sides, and so we get 8 is equal to 2x over 0.5 minus x. All right, so we're going to multiply both sides by the denominator here to get rid of the fractions. So we're going to get 4 minus 8x is equal to 2x. Now let's add 8 to both sides. All right, add 8 to both sides, and we got 4 is equal to 10x. Oops, 8x is what I meant. X is going to equal 4 over 10, which is 0.4. Let's see what the question is. What's the concentration of HI? All right, so HI, X is 0.4, HI is 0.8. There's your answer. If it had asked for the other ones, you would have to subtract. So 0.5 was the, let's answer all the parts. Minus 0.4 is 0.1. And that would be true for both hydrogen and iodine. So there's our answer. The concentrations of H2 and the concentrations of I2, if it were to ask you, would be 0.1 molar. Okay, if they ask you that.